Wait for the recording. Right, thank you so much. Hello, everyone. I'm Ina, your moderator for today. And I would like to appreciate my deepest gratitude for Professor Baba. Thank you so much for joining us today. We
Thank you.
truly appreciate your presence at this conference, and we are really sorry for all the inconvenience that happens before the seminar. We are very excited to hear your thoughts on the topic about mathematics and literacy. All right, so ladies and gentlemen, Professor Baba here is, his work focuses on the intersections of mathematics, literacy, and critical thinking, and how these elements can be integrated into education systems to foster more thoughtful and effective learning. Professor Baba international perspective and innovative approach to mathematical literacy have made him a key figure in the field of education. And then, I am extremely fortunate to have you here, Professor Baba, with us today to share your expertise. So, everyone, please join me in welcoming Professor Takuya Baba. The stage is yours.
Thank you very much for introduction of me. And I'm very happy and feel honored to make a presentation, give a talk during this important occasion of KOPI, KOPI, literacy for pedagogical implications. Title, actually, I have been struggling with titles. I was changing many times titles, but anyway, this is related to mathematical literacy, but not just simply introducing mathematical literacy introduced by PISA, but going beyond that so that it can be really meaningful message to Indonesian audience, I hope. So this is the content of my presentation. Firstly, I would briefly describe the current status of the society, which requires some kind of reading the data, and that is related to PISA literacies. I am putting literacies, plural, not only mathematical literacy and scientific literacy and reading literacy, all those PISA literacy is related to reading the data. So that's why I put plural. And against that kind of international movement, what is the reality of mathematical literacy in Indonesia? Since my area of specialization is mathematics education, although in chapter 2 I expanded including other literacies, but my main focus is mathematical literacy. And after talking about the reality of Indonesia, I was trying to expand how we can look at mathematical literacy a little bit wider, not just PISA. Because at this moment, reality of mathematical literacy in Indonesia seems to be a little bit depressing, honestly speaking. But by expanding the scope of mathematical literacy, I hope we may be able to find out some way out or a kind of solution to that. Number 5 is the socially open-ended problem, which I have been working for the last almost 20 years, and a bit new towards mathematical literacy. And finally, hopefully towards future of mathematical literacy in Indonesia, some discussion can be made at the end. So let me start from the chapter 1. Data-driven society. You may hear something like this, but I was checking International Telecommunication Union report. The data, or this is actually talking about ICT users. Many people now are online. So including older generation, more and more people now using the data. If I focus on Asia Pacific region, just between 2019 to 2004, 24, the percentage increased to 48 to 66%. If this trend continues, I think next to 10 years, next decade, I'm sure majority of them have access to that. What does that mean? So the society is operating by this ICT, and sometimes we call cyber physical system or Internet of Things. Many things are connected with Internet through data or ICTs. So in that kind of society, we sometimes describe by Japanese government, we call society 5.0, not just simply data, but those data is connected. And connection of data made a lot of technology possible. So in that sense, I think big data or those data being connected make it possible to have such things as weather forecasting, promotion of sales, utilizing some of the data and try to see some of the trends of the goods. I'm sure you have a experience, order some things through Amazon, and Amazon provides you. Those people who bought this one can also buy some other goods, or analyze the movement of the tourists. They are trying to see some of the new kind of trends. So a lot of data being utilized, and we can say this kind of things brings us a new dimension of the society. But even such kind of data blurs the border of reality and virtual, even creates fake news. So this is difficult situation. On one hand, it brings a lot of possibility, but also it creates a lot of difficulty as well. So in that kind of society, what kind of things is being asked for us? Read the data, not simply looking at the data, but critically analyzing the data and make a decision on that. And also, it is important to read critically others' decision as well. Because sometimes some people intentionally create their own data, own decision based on the preferable data or created data. So it is very difficult situation, especially AI bring us a lot of new dimension of data or decision. So it is important for the citizen to consider the possibility and also some of the danger of the data or limitation of the data. So that is a situation. Then what kind of things being asked by the PISA study? Um, International assessment, PISA or team study is very, very famous, but especially it's very notable looking at the trends of the participating countries. 2025 is expecting 91 countries. In the world, we have got to 196. So almost half of that is participating. This is really the tremendous impact. We really have to careful paying attention, not necessarily simply following PISA, but what is happening or even critically looking at it. So PISA proposed this kind of things only 2000. So only 25 years passed, but 91 countries are participating. We can see the tremendous effect of that. And PISA proposed, OECD proposed reading literacy, mathematical literacy, and scientific literacy. These are three main literacies. But besides that, like problem solving or financial literacy, those are sometimes those are, extra kind of literacy being tested in particular year. And one thing which we have to understand well is they are not objective of school subjects. They are related, but not exactly objective of school subject. That is important notes, which we really have to be careful about. So the competency expected to demonstrate as a result of school's education. So let us see how mathematical literacy is defined. Mathematical literacy is an individual capacity to to reason mathematically and to formulate, employ, interpret mathematics to solve problems in a variety of real-world contexts. It includes concepts, procedures, facts, tools to describe, explain, and predict phenomena. It helps individuals to make informed decisions and judgment, which are essential for being constructive and engaged citizens in the 21st century. So it is really 21st century material products. And there is no equation, there is no function being written. So it's not directly the objective of the school subject, but as a result of mathematics education, what we want the individual to expect. Especially, you may realize some of the color, this blue one, as a result of that, I think student or individual to make informed decision or being constructive and engaged citizens. So that is the ultimate goals which PISA literacy is aiming at. But before that, what we want them is reason mathematically, formulate, employ, and interpret mathematics by solving problem, by describing, explaining, and predict. So I was analyzing this mathematical literacy's definition. Ultimate goals is informed decision and engaged citizens. And try to find out mathematics or interpret real context through solving problems, explaining phenomena. And this is the same for science literacy and reading literacy. I'm going to share this slides after my presentation, so you can read details carefully later on. So I did the same for all of them. Aims, informed decision. I engaged citizens for mathematical literacy, for scientific literacy, informed decision making, for reading literacy, achieve personal objective, contribute society. So they look in some sense similar and a little bit different, but I can find some of the similarity. And come back to that point later. Let us see. So based on those definitions, what kind of problem are being posted? And this is one of the released items of mathematical literacy. Continent area, Antarctica, Southern Pole. So how we can find out the area of this? This is scale, although this is small, 100, 200, 300 square kilometers, and try to make the square or rectangles so that you can estimate the areas. This is, in a sense, very simple, but you have to understand how to use the measurement, how to estimate these. And this is, very application to the daily life. This is one of the sample scientific literacy. Horizontal axis, average sugar consumption. How much sugar do you take? And the vertical one is average number of decade teeth. How much tooth decade do you have? So it seems there is certain kind of correlation. But some country is below this and some country is above this. So although we take the same amount of sugar, some has more number of tooth decay while the other one is not. By looking at this graph, which one of the following statements is supported by the graph? A, in some country, people brush their teeth more frequently than in other countries. There is no data about tooth brushing. This statement itself sounds very, true. When we brush the teeth, maybe um, um, we don't have, we have less teeth decay. So in some country, maybe they brush their teeth more frequently. Maybe true, but as far as reading this one, this cannot be found out. So we try to find out opinion from data, opinion from the kind of, evidences. And that is importance of this one. And scientific literacy is this one of them. Another one is this is one of the reading literacy samples. Lake Chad. Chad is one of African country and presenting some of the data of the depths in the that lake and the kind of animals. And try to read these one and find out what is the depth and how about which year the graph in figure one starts. So this is not really mathematical literacy, but even reading literacy requires this kind of things. So coming back to the three literacies and similarity and differences, I can say some of the similarity are object, data and text, objective, logicalness and reflection, or explain, evaluation or assessment, and aims and socialness or ethicalness, informed decision or engaged decision or contribution to the society. So these are literacies being required by the OECD. So against such trend, data-driven society or required literacy, let us see Indonesian education status. This chapter, I asked my student to help me to develop. What is intended in the development agenda by Indonesian government? Social transformation. Because digital, driven society, we need certainly such kind of social transformation. For that, 13 years of mandatory education. Even Japan, we have never tried this. So I felt this is very, very high levels of expectation. But it is important for us to, aim at the higher levels. Higher education, qualified STEAM graduates, or in order to attain that, quality of teaching learning is very important. And 75% of workers graduate of secondary or higher education and work in the skills job. Yes, uh, more or less, we all our countries aiming at this kind of, try to improve the quality of education and try to grow, especially in STEM or STEAM education. In mathematics education, what is being aimed? Mathematical understanding process skills, or problem solving, reasoning, proof, communication, or mathematical connection. All these one is very much related to mathematical literacy, which are being proposed by OECD PISA. Let me repeat, OECD PISA is not really the aims of mathematics school education, mathematics education. But as a result of this, they are, proposing, aiming at what kind of competencies each citizen to have. So in that sense, I think these are related to the OECD PISA in a sense. But after um, uh, satisfying these kind of conditions, we expect that a student acquire such kind of mathematical literacy. So against these, what is intended? What is achieved? This is disappointing figure. Below 1C, 1C, 1B, 1A. They are separated into different levels. But I can say all these one is ones. All of them are originally one. Actually, I was a member when we discussed separating one into 1A, 1B, 1C, below 1C. When we discussed PISA, or, organizing committee, we separated into these, different levels. So now 1A, 1B, 1C, below 1C, all of them ones. So majority of Indonesian students belongs to this. That is, fact. So this is really important point which we have to pay attention. By the way, I collected all the data from ASEAN countries, but Laos, Myanmar, Timor-Leste does not participate in this one. But among those participating countries, I can say Indonesia is one of the lowest levels of attainment. So we really have to understand what is happening here and immediate target, lifting level 1s to next level, level 2. How level 2 look like? Level 2 student can recognize situation where they need to design simple strategy to solve a problem. What is simple strategy? Maybe involving one variable as part of their solution, or a more complex mode, such as two-way tables, charts, two-dimensional representation, three-dimensional object. So it's not very difficult. Two-way tables is not very simple, but not very complex. But 81.7% cannot do this. This is really worrying situation. So now I want to see what is mathematical literacy a little bit more deeply. What is the situation, including other countries? So I am trying to look at this one carefully. These different levels of understanding till mathematical literacy. This is a kind of research which we conduct Africa, Zambia. Simple things. There are 5 chocolate, each costs 500 kwacha. How much are they in all? By the way, kwacha is local currency. 5 chocolate, 500. So 2,500 is a correct answer. Multiplication. 5 times 500, 2,500. Using multiplication, correct is 23%. Addition, 500 plus 500 plus 500, etc. Then 36% got it correct. So all in all, correct percentage is 59. Surprisingly, although they got wrong, but orally correct. Orally wrong, 90%. So what, and this is percentage, but let me show you their scripts. 500, 500, 500, 500, 500, 25. This is wrong answer, but you can read the intention of the student. Sometimes 500, 500, 500, 500, 500, 2,500. We may call it in the market, especially 2,500. 500 plus 500 plus 500 plus 500 plus 500 is equal to 2,500,000. No, this is 2,500. If we read that, we can read the intention of the student. 500, 1,000, 1,500, 2,000, 2,500. 5, 10, 15, 20, 25. So all these is a script of the student. So what is surprising here is, although some of them are wrong, usually, said wrong, but even wrong answer contain some of the correctness, or at least some of mathematical ideas. And that is very important. So my image is like this. even among the wrong answers, there are different levels. Some are almost correct. Even among correct answers, there are different levels of correct answers. We have to understand these different levels of understanding. Otherwise, if we simply say wrong, how can they be corrected? How can they be promoted to correct answers? Or even among correct answers, if their mathematical thinking is, low levels, how can they be promoted higher levels? Those are, basic ideas of this. 4.2, identification of different levels of errors. Quite similar to the one which I have shown, but different thoughts are given. Identifying where the student got errors. Reading errors, comprehension errors, transformation errors, process skills errors, and encoding errors. Reading errors, some of the students cannot read the question or problems. So those, Zambian case, they cannot read those, sentences. They are given five chocolates and each costs 500 kwachas, something like that. And maybe some of the word is difficult, like chocolate. They cannot read that one. Or comprehension level. They can read, but what it means, they cannot explain. It's interesting. They are able to pronounce it, but they cannot explain the meaning of the sentences. Or student can select appropriate mathematical, they can explain what it means, but when they are asked the operation, mathematical operation, they cannot say whether that addition, subtraction, or multiplication. They get confused. Or they can say, but they cannot, conduct that calculation. So maybe in mathematics class, we put too much emphasis on process skills only, but there are different levels of errors. In that case, we may not be able to properly address the student difficulty. In fact, in Thailand, we collected this data some time back. Level 2, see, although they are able to read those sentences, they cannot, understand the meaning of it. For this case, particular case, gave half of them. That one, 32.5% of the students made mistake because they could not understand the phrase of half of 16, half of them. So by looking at the cause of the errors, we are able to identify some of the our strategy, how we can address those weaknesses of the student. So let me repeat, different levels of understanding, but here, different levels of errors. Next one, this is another interesting research. Although they can understand those sentences, but they cannot really interpret properly mathematical questions. This is called P problem. It's problematic problems. This is from Belgium. The problem is a man wants to have a rope long enough to stretch between two poles. Two poles is 12 meters apart. Unfortunately, we don't have a 12 meters rope. We have only 1.5 meters rope, many of them. How many do we need? Okay, 12 divided by 15 is 8. Do you get it? No. This is sort of mistake. In order to put a rope across, we needed to tie. So we have in this problem, actually, we expect allowance of tying portion, maybe 5 centimeter, 10 centimeter, we have to deduct from 1.5 meter long of ropes. So that's what they expect. Then they did a lot of group discussion or de-wording, how original problem by the group work or even single individual student, trying to de-word so that it can make sense. Although this is not really a good problem, but this is actually from original, so I didn't change anything. The head of Italian army decided to make a war against the U.S. army. This is, a very strange setting. So you don't really have to use that. But the point is, after giving this one, individual student or group work, they try to reword this one. And this is a point how many parts of the sentences are reworded by the student. And group work has got more rewording. But interesting thing is, reworded text built by students show the presence of useless details. So like the soldier eat tomato pizza and had a general talk. This is not related to mathematics, but I think we really have to be careful. Teachers too much concentrating on mathematical component, while students, they want to make sense of it. So this is useless in terms of mathematics. But for the student, this is important details. And that we should understand. And that we should address in the classroom of mathematics. Those students who decided to convert the story text in something closer to their own life. In the fifth grader classroom, Madonna Aswanta, there are 450 children. So anyway, they changed the context, which is close to them. So this is interesting kind of efforts being done by Belgian team. So PISA, mathematical literacy and context. So when I come back to the mathematical literacy by PISA, PISA talk about the context like this, the aspect of individual words in which the problem are placed. The choice of appropriate mathematical strategy and representation is often dependent on the context. So it seems mathematical strategy and representation is being influenced by context, and the context is the aspect of individuals, and they give personal, occupational, societal, scientific. Okay, let me show you some interesting examples. Personal. I have $10 and I am given $20 by my mother. How much do I have in day all? Is it 10 plus 20 is equal to 30? I had $10 given $20 by my mother. So how much in all? So 10 plus 20 is equal to 30. Okay. I make 10 jacket as I am a tailor. I make 10 jacket and 20 pants. How many sets of jacket and pants do I have in all? Can I say 10 plus 20 is 30? Because I am asking how many sets societal, 100,000 people in the city A, population increased by 10% from 1980 to 2000. It increases 20% again from 20 to date. How does the population has grown in total? 10%, 20%? Is that 30%? But put 10% of solved solution and 20% solution together. Is it 10%, 20%, 30%? If we look at it carefully, not just simply the type of context which influence mathematical strategy, I think it's very important for us to pay attention mathematical structure or mathematical sentences. So, summary of mathematical literacy. Mathematical literacy is actually talking about real world and mathematical world and try to going around this one. So real world problem converted in mathematical problem. After solution, bring back to real world once again. So the type of problem solving, which I said, like Zambia case, different level of understanding, simply solving mathematical problem to mathematical solution. Even that, there are different levels of understanding. And I think utilizing Thailand data, Newman approach, different type of errors are happening, mathematical problems to mathematical solutions. Belgium case, to bringing real world to mathematical world and finding out solutions. There are adding mathematical meaning, but sometimes unintentional things are being brought by the student, or a student understand the peculiar way of mathematical. And mathematical literacy is going around those. So actually, what is being intended mathematical literacy in OECD PISA is really having a wide spectrum. So it's not simply mathematically solving this, not just simple mathematical procedures. There is a lot of things are being involved. So in many cases, including Japan, teachers and students tend to disregard the non-mathematical component of mathematical problem. Well, this is not the mathematics, so let us concentrate on mathematics because this is mathematics class. However, it is important to understand problem context and out of that problem context, extract mathematical relation out of that. That is the important point. What is required here is not beyond simple mathematical calculation or beyond simple reading of the problems. Reading, yes, important, but how we can read mathematical component out of that. So in that sense, students have to think extensively between calculation problem and reading the mathematical problem. So proposal of socially open-ended problem, I proposed 2007, some time back. But we have been conducting a lot of research around here. So let me introduce so that it can give some of the idea to you. This is related to making a decision using the data in Chapter 1 and Chapter 2 OECD literacies, reading data and context, developing explanation and evaluation, and aim is socialness or ethicalness, not simply finding a solution of mathematical problem, but it should be related to, connected to the socialness or ethicalness. And chapter 4 is thinking extensively between calculation and reading mathematical problems. Very simple in that way, but in a way, this is really a new approach to mathematical problem. We call this is hitting target. At a school cultural festival, your class, this is actually grade 4, and offers a game of hitting a target, like this. Yeah, you know darts. This looks like a dart, but darts is a sharp end. So since this is a primary schools, they throw the balls at the target. And that balls hit 5-point area, 3-point areas, and one border of 3-point and 1-point areas. And the problem is, how do you give the score to the student? Yeah. This is interesting. The result is 5.3.3, 5.3.3.1, 5.3.3 plus 1 plus 1, 5.3 plus 2. And the reason is kindness to the first grader, because the children who throw the ball is a first grader, and the team, the group of people who organize this game is fourth grade. So they are small children. Let us be kind to them. Yeah. And 18 students, actually this is a number of students, and out, this is 20 students who chose fairness and equality to the whole class. So kindness to the student, but no, even grade 1, we have to be impartial, we have to be fair. So those students chose 5 plus 3 plus 2, 5 plus 3 plus 1, or 5 plus 3 plus 3. And this is actually the kind of discussion. So say, how much are you going to give? I thought of the firstly, I wrote 5 plus 3 plus 3. Instead of that, 5 plus 3 by 2 is equal to 11 points. I'm going to give the 11 points because the first grader should be welcome. So this is thinking about the first grader. And instead of like this, we can rewrite no parentheses. So 5 plus 3 times 2 is equal to 11. And whom did you think of, SJ? I thought of the first grader. So teacher said, let me write kindness to the first grader. So teacher try to interpret what students say and sometimes gives some kind of facilitation to the student. While the ball, the next idea is the ball is on the boundary of 3 points and 1 point, but 1 point area is a little bit bigger. So let me give 1 point. 5 plus 3 plus, the final one is 1 point and 9 points. Or the others, if the middle, just the middle in the line, instead of 1 point, I'm going to give 2 points. And the other student, I thought 3 points to the first grader, but if you, the other student, if whom did you think about? And this student say, I think about all the people who play the game because I want to be impartial all the students. So after those discussion, interesting thing is, vertically, values at the resolution, self-resolution at the beginning. And this one, after the discussion, final selection. They chose 2 times. At the beginning, after the individual work, after the discussion, they choose again. Some of the students change their values, fairness to kindness, because they think, okay, it's better for us to be kind to the first grade student. But again, some of the students who said kindness to the first grader, okay, let me change to the fairness. So after the discussion, they change. So even they say, first grader will be happy and come here again. But it's good for us to give bonus to the first grader. So like that. So in that sense, they change this one. So comparison of socially open-ended problem to nurture mathematical thinking and judgment based on mathematical thinking and associated values, utilizing this kind of, discussion. So open-ended problem, but at the same time, they are related with social values. So I see some kind of relation between social open-ended problem and mathematical literacy. At the end, mathematical literacy to make informed decision and judgment, being constructive and engaged citizen. Here, effective or social open-ended approach is judgment based on mathematical thinking and associated value, etc. So towards the future of mathematical literacy, after seeing this one, I can see different levels of understanding, different levels of errors. So try to understand these one and enriching some of the discussion in the classroom. Because between intention is quite related to the PISA studies, but achievement is very poor. Between intention and attainment, there is implementation. Implementation in the classroom by the teachers. So I think it is really important what kind of role teacher can play. What kind of problem do you or do teachers want children to solve? What kind of competencies actually do you expect them to demonstrate? I have got to some of the assessment problem by my student, and I was thinking towards that. Towards the end of the year, several stores provide some discounts, such as 50% discount, buy one, get one. Let us think story related to this and try to discuss what kind of story can you think of during the lesson. And they may come up with a different, instead of 50, 20%, or after 20% towards the end, let us add still some more bonus. Or buy one, get one is too much. So let me say buy three, get one, or those kind of things. So related to this, they can have a lot of discussion, and based on that, we can think about their characteristics. That's what I meant idea of meta problem. Let the student to solve not only one problem, but let them think characteristic of problem. So being proposed some of the different kind of problem, how different those problems are, how similar those problems are. So in that way, they can see meta kind of cognition about those problems, similarity or differences. This one, recently I read management theory. This is not mathematics education or even education, but management theory and context thinking. And they are saying from context thinking to context thinking. Content thinking is more physically recognizable things, voice, letter, numerals, and objectively understood. While context thinking, we have to read those background information or context subjectively understood. So if we encourage this one, this is to interpret subjectively interpret the problems or context. There is a possibility of active learning, but also danger of deviating from mathematics. Because if we encourage subjective interpretation, they may, include their subjectivity, and they may, play with this kind of things, and involves a lot of non-mathematical component of it. But what I can say, it is really the teacher's role. Teachers let the student freely discuss about their experience in problem solving and take up the mathematical pattern within it. Sometimes students utter what the teacher don't expect, but you should not be upset. If we deny that teachers deny all those ones, students may lose their proactiveness. They may think, teacher will say everything, so let me not, talk. We wait for the teacher to say. Or if the teacher accepts all, the student may lose sight of mathematics because it involves a lot of non-mathematical component. So it's really the teacher's role. We have to pay attention mathematical component, but at the same time, we should allow some proactiveness by the student. As precondition for the lesson, rich experience for the student is very, very crucial. Otherwise, they cannot come up with a lot of interesting examples. In the long term, not just simply solving the mathematics, but ethical consideration, 21st century skills, or those kind of citizenship is very important. Sorry, I'm extending a little bit, but thank you very much. This is all. Thank you. Terimasu kasih.
Terima kasih, Bapak. Thank you so much for the insightful talk. We truly appreciate you sharing your expertise with us today. Well, from your presentation, we know that literacy, mathematics, scientific, and reading is indeed crucial, especially in facing the era of Society 5.0. So, I have a question here while waiting for a question from the audience. Related to the mathematical literacy, how can we improve the mathematical literacy in the society to better navigate the complexities of big data? So this is what you explained at the beginning. I was wondering how to better navigate the complexities of big data, especially when it comes to detecting fake news or misinformation in the news. Thank you.
So I'll answer now.
Yes, you
Okay,
may
thank you very
answer
much.
directly.
Actually, big data is even, I think in a Japanese context, really difficult, but I think we have to construct from very, very early stage. So even primary or even probably early childhood, how they deal with those data, and at the same time, what is the genuinity of that data? What is, fake kind of data? We should not think too complicated way. But even in primary, I think we can talk a lot. And based on that, gradually we have to construct. And other group which we are conducting, we are trying to deal with socially open-ended problem from early childhood till university. So I think not simply jump to the higher levels, but starting from low levels and including those discussion about how we can interpret those is probably important. And I was saying probably some of the this one. I think this is interesting example here. I made this one, but probably some of the students, if without really understanding carefully, they may simply add 10, 20. Okay, let us put them together. So reading those data, paying attention to the number or problem structure, all those one is very important. So I think we should start from the very early stage. That's what I can say.
All right, thank you for the answer. So we do really need to start from the very early age. That's what I get. We have another questions here in the chat box. Let me read it for you. So this is from Ibu Laili. The question is, in what ways can teachers encourage interdisciplinary learning between mathematics and literacy to enhance overall academic achievement? The relationship between mathematics and literacy.
Thank you very much. In a sense, it's easy. In a sense, it's very difficult. It's easy. What I say is, when we started the problem, especially at early grade, children can bring a lot of non-mathematical component. So in that sense, I think they can easily come up with if teacher allow. So what is important is It's related to this. It's related to this. Um, Teacher should not strictly limit. That is not mathematics. So you are not supposed to talk. The moment you say, children feel, okay, let me not talk. So they close their mouths. So what kind of classroom culture you are able to develop? So at least as a teacher, you should ensure a kind of classroom culture. Whatever they say, they feel safe. They will not be criticized by teacher or scolded by teachers. So they can say whatever they want to say. At the same time, teacher have to control. If they deviate too much, wait a moment. Yeah, that is not very much related to today's topic. So we have to focus this topic. So I think you have to, as a teacher, you have to think very well how much you can allow. So in that sense, you can easily invite a non-mathematical component beyond mathematics. It's not very difficult so long as you create a good classroom culture. That's what I can say.
Right. I guess that answer the questions. So we also need to consider to make it balance between the teacher and learner autonomy in learning. All right. Do we have another question here? I guess not. So, okay, I guess that's all. Again, thank you. Oh, well, one more here. Let me read it for you. The question is, how can socially open-ended tasks be possible to support Indonesian students with low proficiency in mathematical literacy? So we're talking about student with low proficiency here.
Uh, I think uh, there is a famous expression. There is no child who cannot study, but there is teacher who cannot teach those students. So, although you can say low performance of the student, so long as teacher has a good capacity, I think we should be able to teach. Anyway, so I think our socially open-ended problem is not very complicated, very difficult things. So um, this one, the example which I showed, this is to a certain extent complicated because this part is talking about how much score we are going to give, but uh, we can make it a little bit simpler, and even some of the cases a little bit simpler. There is 5 cakes, and we are going to share those 5 cakes. Father, mother, grandmother, grandfather, and my sister and me, 6 of us. How are we going to separate or share? And they say 5 divided by 6 is 5 over 6. Yes, at the same time, uh, I didn't say equally. So some of the students, okay, grandpa, grandmother has got a diabetes. So we should give them half of it. And mother, father, me and my sister give one. No, me and my sister is a child. We should be given priority. So two for for children, and only one remaining to the adult. So they talk a lot. Simple things. I'm sure Indonesian children can say that. Only that teacher is very important. You should not lose the grip of the discussion. Yeah. So that's what I can say.
Thank you. That was very inspiring. Thanks again, Professor Baba, to sharing your expertise with us today. Let's give one last round of applause for Professor Baba here. Thank you so much. Thanks again,
Thank you
everyone,
very
for the
much.
questions and enjoy the rest of the day. Thank you. It's a wrap.
Bye.
I'm Inda, and see you again next year, inshallah. Thank you.
Thank you.
I give the screen back to the moderator.